Hey man, you wanna play some pool?
Sorry, man, I gotta do some physics.
Come on, we can do both.
How?
I'll show you.
For our second experiment, we're basically having a stationary ball that will be colliding with a secondary stationary ball, and all of this will be initiated by this moving ball. So basically, this ball will be hit by a force. It'll travel, collide with this ball, and this ball will collide with this ball, and we're basically seeing how momentum changes throughout these collisions. Set up this equation for the conservation of momentum, where m1v1 was the observations for the white ball before the collision, m2v2 we're finding, and mfvf is the velocity and the momentum of your white ball after the collision. So we set it up and we canceled all the masses because they're the same, and we found the velocity of the white ball before the collision occurred by subbing in 0.710 meters divided by 0.221 seconds to get 3.23 meters per second. And then we, as I said before, we got this number by using this equation right here to basically eliminate and to find for V2. V2 is the speed of the orange ball after the collision with the white ball, and it's important for our second part of the experiment because it acts like a bridge. So we sub in 2.93 meters per second, and then we need to find these two extra sources. 1.52 meters per second is the velocity of the orange ball after the collision with the yellow ball, and this was founded by subbing in 1.10 meters by 0.723 seconds to give us 1.52 meters per second. Basically, rearranged the equation and we isolated it for V3 to get 1.41 meters per second as the speed of the yellow ball after the collision occurred. Okay, so for the final part of our experiment, we're going to be conducting it in such a manner that both the balls will now be moving towards each other, and we'll be seeing how momentum is affected in this case. So both these balls are at a distance of 53 centimeters between each other, and we'll get the other measurements by looking at the video, so let's go on. The velocity calculated by this was 1.96 meters per second. Here you can see that there's a negative sign. This negative sign is in place because one ball was moving in the positive direction while the other ball was moving in the negative direction. This was arbitrarily set up, so it's not really important which one was which. When this equation was set up and it was calculated, it meant that we got a final momentum of 0. Now, after the collision occurred, the balls moved apart 48.5 centimeters from the collision point. They both moved the same distance at the same time, so their velocities were the same again. This was 1.43 meters per second. Here, the ball that was actually moving in the positive direction before the collision was now moving in the negative direction after the collision, which is signified by the minus instead of the plus. All that being said, the momentum again was found to be 0. Here, the problem, as I talked about before, was that the velocities were different. That means that momentum isn't really useful in talking about why it's different. We actually have to look at the conservation of energy. We did so by looking at energy initial equals energy final. In this case, kinetic energy initial of ball 1 plus the kinetic energy initial of ball 2 should have equaled the kinetic energy final of ball 1 and the kinetic energy of ball 2 final. So we basically took these values and we just subbed them again. Instead, we use an mv squared divided by 2 formula. And we set it up, we solved it, and we found that for the initial part, the energy was actually 3.84, while the final energy was 2.05. So there's a loss of kinetic energy, which we'll talk about now. To conclude, it was found that the experiment was only 53.4% effective because energy was lost to thermal and sound energy. Thermal energy was lost when the ball was rolling across the floor, while sound energy was lost when the ball collided with the other one to produce sound. This is the end of our experiment. Thank you for watching.